When the program starts, the main method is the entry point. Here, a new instance of the bank class is created, which will manage all accounts and transactions throughout the session. Then, a loop begins, which repeatedly shows a menu to the user. The options include creating a new account, withdrawing, depositing, transferring funds, printing account details, viewing transaction history, and quitting. At this point, the system has no accounts. So, let's say the user chooses to create one. This triggers the doAddNewAccount method with the bank object, and the program prompts the user for a name and an opening balance. Let's add an account for John with a balance of 500. A new account object is created and added to the bank's list of accounts. Next, if the user wants to withdraw money, the program calls the doWithdraw method. This method first uses getAccountFromUser to find the account by name. If it exists, the program asks for the amount and creates a withdraw transaction object. When execute is called on the transaction, it calls the withdraw method of the account. If the withdrawal is successful, the transaction is marked as successful and stored in the bank's transaction history. The same pattern applies to deposits and transfers. For transfers, a transfer transaction combines both a withdrawal and a deposit and ensures that either both succeed or both are rolled back. The print option displays the current balance and name of an account, while print transactions history lists all previously executed transactions. This loop continues until the user chooses quit, at which point the program ends gracefully. When we look at the account management system, it's not just about getting things done. It's about how those things are structured and protected under the hood. That's where the 4 core principles of object-oriented programming come into play: abstraction, encapsulation, inheritance, and polymorphism. Let's start with abstraction. The user never sees how the system processes a deposit or a transfer behind the scenes. And that's the point. The transaction class hides away all the shared behaviors, like checking if a transaction has already been executed or needs to be rolled back. When we run a deposit transaction or transfer transaction, we're calling execute at a high level without needing to worry about the inner mechanics. Those are handled within the subclass. So the program stays clean, and we interact only with what matters. Next, encapsulation. This is about protecting the internal state of objects. Take the account class. It keeps the balance private, and the only way to change it is through controlled methods like deposit and withdraw. These methods include checks, for example, not allowing a withdrawal that exceeds the balance, ensuring that the account always stays in a valid state. Similarly, the bank class doesn't expose its account list directly. Instead, you have to go through addAccount or getAccount, which keep things safe and consistent. Now let's look at inheritance. Instead of writing separate logic from scratch for each type of transaction, we create a base transaction class that defines common properties like success and methods like execute and rollback. Then subclasses like withdraw transaction and transfer transaction inherit that functionality and customize the behavior for their specific purpose. So when we create a new transfer, we're not reinventing the wheel, we're just extending it. Finally, we come to polymorphism. This is where things get powerful. The bank stores all transactions, regardless of type, in a single list of transaction objects. Even though some are deposits, some are transfers, and others are withdrawals, they're all treated the same way. When the system calls execute or print on each one, the correct version runs automatically based on the actual object type. This lets us work with different types of transactions through a single unified interface, and that makes the system flexible and extendable. Together, these four principles shape the structure of the program, not just helping it run, but making it clean, reusable, and easy to maintain.